I do not have anyone on the Zoom meeting yet or on YouTube, but still I'm lesson 8.3. Okay, if we have guests eventually, we'll just go for that. Okay, let me just make sure I'm making some arrangements here, and then I'm gonna start with this right away. Okay, so Canvas. It's gonna take a minute or so, so eventually. Not here yet. Okay, I'm gonna do this. I'm going to end this. Let's see if it works. All right, so I'm gonna start already, and then, oh, hello. Hi, Kaya. And waiting a couple of minutes because I thought there was a problem. And okay, so if you all can hear me, I'm gonna start already. Just remember that this is also being recorded on YouTube live, so you will be able to get back to this video eventually if you want to review the topics we're going to go over today. Okay, so I'm glad you're here. I'm going to mute all of you. If you have a question, you can type that question on the chat right here. You will see it on your right. Okay, so let's begin. If you can hear me, hopefully everything's okay. Yeah, let's begin. So I'm going to put everything right here. Give me a second. I'm going to adjust this. But yeah. Okay, guys. So to send the mathematical part of it easier. So what we're going to do with section 8.3 is that we're going to talk about, and I got it here, we're going to talk about midpoints and segment bisector. So I'm going to write the concepts we're going to go through, okay? So we begin with midpoint and segment bisectors. We're also going to talk about, the next part is the midpoint formula. And finally, we're gonna talk about the distance formula, okay? So, especially these two require some, attention to detail and segment bisector, okay? Those who are coming here, I'm going to mute you because if you have any questions, then you can, find missing information. This is the usual game. Probably you may have noticed that already, but that's how we deal with this. We try to understand and make sense of a concept, and then we make sure that you understand the concept, and then it is completely understood by working on some exercises, for the most part, having you find missing information. Okay. Hello, Anna. I am muting everyone as you enter here. So give me a sec. Okay, great. Now I have this option. So yeah. So hi guys, good to have you here. And I think that as I told you, with more time in advance, now we have more participants in here. Just to remind you, this video will be uploaded on YouTube. I'm going to post the link to this video on the same module, and go back to it and review the sections. Another reminder, guys, even though I posted several sections, just make sure that you do it as if we were on our regular schedule. You have class on odd days, so you can access to those lessons on odd days. So we are now doing 8.3. You didn't have to do everything that where we should be. And also, just know that even though I have some due dates have the possibility to do everything you have to do. Okay, so let's talk a little bit about midpoint. Okay, and I'm going to explain the concept as I solve a couple of exercises. Okay, so let's begin. Okay, section of monitoring progress. We're going to do exercise number 2. It's almost at the bottom of that page. Okay. So the first thing is they show you a segment. It's this segment. And it's segment PQ. And it happens to have this point. Like to understand, here it is. Because they show you these 2 marks here and here, implying that this segment PM is equal. So I could say that this segment PM and segment MQ, and can you see this line on top of the equal sign? That's how you express that in geometry. So PM. So the thing is that exercise number 2 on that page is showing you this segment PQ, but M happens to be the midpoint. Okay, so M is the midpoint, and also they are giving you this information. They give you the measure of the portion MQ. So it is 2 2/7. Okay. Find. So what we have to find is find PQ. All right. So if you are given this and you know that this is, cut in 2 halves, so it's basically this plus this is going to be the whole thing. And if I know that this is 2 2/7, so guess what? What is the measure of this? The same. So this is also going to be 2 2/7. With that in mind, then I will be able to say, let me finish the exercise right here. I will be able to say that PQ, right? I'm sorry. That PQ is, the magnitude, the measure of PQ is equal to doing this addition. So it's going to be PM, right? Plus MQ, 2/7. And because I can also say that that's the same measure for PM. So with that in mind, I can do 2 2/7 plus 2 2/7 on top over 7. Okay, and we have the same thing here. Again, 2 times 7 is 14, plus 2 is 16. So 16/7 plus 16/7, we have the same denominator. We don't have to change anything. And 16 plus 16 is 32. As long as you show it like that is okay for me, but it seems like big ideas probably will ask you to convert it. 32 divided by 7. Yeah, and then you work it out that way. So it's 4 times, it's 28 in here, and then this is 5 as the remainder. Okay. So we have this number, this fraction in mixed form is going to be 4 5/7, and that's the answer. Okay, that's the measure of PQ. All right, I guess that's all. Am I right? Did I do it right? Let me just confirm. This is 7 times 4 is 28, plus 5 is 32. 32/7. We're okay with that. And I just want to make sure that we're doing the right thing. It seems like it. Well, I don't know. There is something that is not working here. Give me a sec, please. Yeah, my bad. This is not a 5 here. It's a 4. Yeah. Made a silly mistake. Haven't have. Probably. Oh yeah, I'm going to take this this question, Jake. So, well, as you can see, what I did was adding this and this as well. But this halves length is 2 2/7. Okay. Hopefully now you got it. If not, just send me a message on the chat, and then we can discuss it when I finish. Okay. So keep that question if it hasn't been answered already. Okay. So now we're good with this exercise. Now I'm going to move on with another one. Okay. So I'm going to go now to question. So sorry, page 397. So on page 397, we have this. I'm going to do exercise number 4. Okay. Number 4. I was making up my mind between 3 and 4, but we're going to do number 4. Okay. What this exercise is showing you is the following. We have this segment. We have now this is what we transversal segment, like a line that intersects the segment at point M. So this line, and by the way, it has the label N. So line N is what we call a segment bisector. Okay, just for definition. And what it does, as I told you, that when bisecting means that you are cutting something in 2 halves. Okay, so we have, and this exercise is telling you the length of RM is not a number, it's giving you an expression. The expression is 4x plus 3. And this segment MS measures 6x minus 12. Okay, and here's the thing. Because we have a bisector, it means that, remember, RM is equal to MS. With that information, I know that I can set up an equation because I can equalize these two. I can set this expression equal to this expression because of the concept of the segment bisector. What does that mean? I can say the following. I can say, all right, so if these two are congruent, it means that 4x, actually, I'm going to write it like this first, because I want to walk you through the logic of that thinking. I can say that RM, yeah, is congruent to MS of each segment, okay? So with this in mind, I'm going to go back to the graph and see, okay, what is the measure of RM? It's 4x plus 3. Okay, I'm going to write it down, 4x plus 3. And what is the measure of MS? Is this 6x minus 12, okay? They're canceled, so I just have this number 3 left in here. And what do I have on the right? 6x minus 4x is 2x, and then minus 12. So what is the next step? I'm just going to solve for x. Remember, it means I'm focused on this x, so it means that I'm going to get rid of anything that is surrounding x. So the first thing I can do here is adding 12. So I'm adding 12. All right. So this is canceled. So 3 is dividing by 2, which means that x is equal to 7.5. But here's the thing. Some people might think, oh, I'm done. No, because what you just did was finding what x is. So we're just halfway through, right? Keep that in mind. All right. Yes, or I'm going to plug it in here, for example. So this is going to be, so Rm is 4 times x, but we already know what x is, so I'm going to multiply it by 7.5, and then I add 3. And I just have to solve this operation, okay? 4 times 7.5, it's a 30, plus 3, that's a 33. What did you just find? You found out Rm, okay? Rm means the length of this half. But what is the question? The question is finding Rs. It's the length of the whole thing. What do you think? 33 times 2, which is 66, okay? Hopefully it was clearly explained. But anyway, remember that since this is going to be on YouTube, you can, rewind a little bit, pause it, make sense of it. Now it's, the whole thing is on screen here, so you can make sense of this exercise, okay? So I'm done with this. Now, let's keep going. Yeah, hopefully I'm not going to spend more than 35 minutes probably on this video. This is going to be the longest one of this chapter, I promise. I think 8.4 is going to be shorter, but this topic contained more, details that we had to work through. Okay, so the midpoint formula. Solve one of those exercises. Okay. By the way, while I finish this, I remind you, you can send me email. Just send me an email, right? And you can go to Canvas and, get back to those videos as well. So now I'm going to do exercise. Okay, I'm going to go through page 398. And I'm going to, so here's the thing. We are given the endpoints. The endpoints of a segment, let's say this. If we have A, B, and C, we say A and B are what we call endpoints, whereas C is what we call the midpoint. Okay, so hopefully now it makes sense to you. Okay, now give me a second. So now, what we do at this point of time, draw, but let's just do it to give you some sort of an idea of what we have to do here. So we have the endpoints A, B. So A is located at 1, 2. So 1 and 2 here. So here is A, okay, with coordinates 1, 2. All right. And B, so A is located at 1, 2, and B is located at 7, 8. And the question is, find the coordinates of M, which happens to be the midpoint, okay? So we already have A. Now let's locate B. B is located at 7, 8. So 1, 2, 3, 4, 5, 6, 7, and 8 up. So 1, 2, 3, 4, 5, 6, 7, 8, somewhere over here. So I'm sorry. This is where B is located at 7, 8. Okay, so what do we have? This segment right here. Yeah, sorry, it's not perfect. And now we need to find the coordinates of M. We don't know them yet. All right, our mission, we have to find it out. But remember, midpoint means that it's halfway through between the endpoints. Remember that. Or if you are given the midpoint, you know that the distance you go to one endpoint is the same that you go to the other endpoint. All right. In here, look at this. If you go, let's begin. We have to find the x value and the y value. All right. I'm not going to use the formula here because I want you to notice what happens. It's really simple. Look at that. For x, you start at 1 and then you finish at 7. Okay? What is halfway through in between 1 and 7? Try to make sense of it. If it doesn't make sense, so you might think about this. The midpoint, the x value point is what is halfway through between 1 and 7. I already know that, and probably you already figured it out. It's a 4, obviously, right? Because it's 3 steps to 4 and then another 3 steps to 7. But if sometimes it might be a little bit hard to find, what you do is, okay, you're going to add them and then divide by 2, right? Because 1 plus 7 is 8, divided by 2 is 4. So I already know what is halfway through here. So m is with the y value. If you go from 2 to 8, what is halfway? Okay, you can count, you can figure it out in different ways. But it's like, okay, if you go 3 steps, then you are at 5, and then 3 more, and then you're at 8. So that's the midpoint, you know. But if you are having some issues with that, so all right. In y, so I have 2, and then I go to 8, and then I divide by 2. So 10 divided by 2 is 5. So it's going to be a 5 right here. And you are going to be asking yourselves, what happens if I get negative numbers? Be careful with negative numbers, but you do the same thing. When we are adding negative numbers, be careful when you do that. And then when you add the 2 numbers, then you divide by 2, and then you will find those values. Yeah, pretty simple. Sometimes you are going to be given the midpoint and one of the endpoints. So, well, figure it out. If you have questions about that, you can contact me, but I'm going to leave that for you, okay? But it's, same idea, same logic. So hopefully you will figure it out. If not, anyway, contact me because I can help you. All right, I'm going to do the last one. We're going to talk about the distance formula, right? So I'm going to go to page 399, and I'm going to solve example 4. Okay, probably that was already in your your reading, and you had to answer some questions. But anyway, I'm going to go through that. Right. So we have, what? Actually, I am going to use this. It's going to be much easier for me to work it out this way, because we have to do the same thing. Yeah, so I'm going to solve this, and I'm going to use now distance formula. But hopefully the way I do it will make sense to you. So let's see how it goes. Look at this, guys. The distance is either simple or complex. Let me tell you why. Because let me show you another point here that is located at 1, 4 between A and C. Can you see that it just had to go 1 and 2 steps up? So the distance between point A and C is 2 units. All right. When it's vertical, you just have to count how many intervals you have to go up or down when it's vertical. When it's horizontal, you have to do kind of the same thing. Let's say that we have point D over here, maybe. All right. Which means that we are located at point D. Point D. Sorry, look at this now. So here, this is point D that is located at 9, 2. Okay. So can you see that they are at the same height? So it's a horizontal distance. It's pretty simple as well. You just have to say, okay, if I go from 1 to 9, so the distance is 8 units. Simple. So again, vertical or horizontal, you just have to count how much you have to go from one point to another, horizontally or vertically. It's pretty simple. But when it is land, that's when we have to use the formula, distance formula. But let me show you how it works, okay? Because you see, for some of you, it's going to be some kind of, probably it's going to be complex. But I want to make it easier for you. And making it easier, it means that it's going to make sense for you. Because you might think, okay, the distance from A to B is I measure a horizontal distance and then I add it to the vertical distance, but that is not true. Okay, be careful, because it's not going to work like that. What I do is anyway, you take into account how much you have to go. In this case, horizontally, I had to go to the right. Can you see? And then vertically, I had to go up. I have to take those into account. So let's count them, okay? And in order to get some help, I'm going to do this. Can you see that I'm drawing this dashed line over here and this dashed line? Remember that this is a 90-degree angle, okay? And they are perpendicular. So I'm going to count first how many steps you have to go horizontally. If you go from this point to this point, remember, you go from 1 to 7. So it means that this is 6 units, you know, 1, 2, 3, 4, 5, and 6. So this is 6 units, okay? And then from when you reach to this point, and then, you know, you have to go up, then you count how much? 1, 2, 3, 4, 5, and 6 as well to be the same numbers. But what you do is this. So the distance, all right, now we're going to say this. The length of AB, which means the distance between A and B, is, I am going to take the horizontal distance, which is 6, and you are going to square it, okay? It's the first thing. Horizontal distance and square it. And then you're going to add vertical distance, which is 6, okay? So AB is going to be this. 6 squared is 36. I can bet that's 36, and this is the square root over here. So AB is going to be the square root of 72. Use your calculators, and then you got it. All right. This is approximately 3 root 8. You find it, okay? But this is irrelevant because the calculator is going to give it to you. You know, it's the square root of 72. But now you know how to solve it. Again, when you have any segment on the coordinate plane, you need to make sure how much you have to go horizontally and then vertically from one point to the other. And what are you going to do? You're going to take each of these distances, the horizontal and the vertical one. You square each of them. Then you add those numbers, and then you take the square root of that number, and that is the distance between this point and this point. Okay. So I'm going to write here. Let's say it's some kind of 8.6. Okay. So this is going to be 8.6, and I got it. Okay, 8.6 right here. I might be wrong in here. Okay, so hopefully you can understand this pretty well. You can work on your quiz. You can work on your lesson. You can work on your big ideas math. I'm going to be sending some emails to make sure everything's doing well. But this is all for now, unless you have a question to make. So I'm going to be 1 more minute in here, waiting for any question you might have. And we can call it a day. And